So starting on page 16, what we are doing today is called linear programming. It's going to put together everything that we've done. So you're going to have to write a system of inequalities, you're going to have to graph them, and then you're going to have to find the maximum or the minimum like we did on today's classwork. So starting with the fundraiser problem. Your class plans to raise money by selling t-shirts and caps. The plan is to buy the t-shirts for $8 and sell them for $12, and to buy the caps for $4 and sell them for $7. The planning committee estimates that you will not sell more than 120 items. Your class can afford to spend as much as $800 to buy the articles. How many caps and t-shirt sales are needed to maximize your profit? Okay. The most important information is in the question that you all have right here. So how many caps and t-shirt sales are needed to maximize your profit? Our two variables are what we are solving for. What are we solving for in this case? What do we want to know? Josie?
The number of caps and then the number of shirts.
Yeah, the number of caps and t-shirts that you need to sell. So that's going to be our X and our Y. Now, if you write caps and t-shirts, am I going to accept that?
No.
No. Caps, X is the number of caps sold, or that I need to sell. Y is the number of t-shirts. Okay, write an equation for the objective function. Okay, if you are the person that is running this fundraiser, what is your objective? What do you want to do?
Sell more than 120 items.
You want to sell a lot of items, right? Because what are you getting? Money. Okay, so when it says maximize your profit, whatever you are maximizing, that is your objective. Okay, so we need an equation. Our profit, how much do we make off of each cap? Miranda?
$7.
Close.
$3.
$3. Lucas, why 3?
Because you get them for 4 and you sell them for 7.
Right. So we sell them for 7, yes, but we had to buy each one for $4. So we make $3 off of each cap. Likewise, how much do we make off of a t-shirt? $4. So we sell them for 12, but we had to pay $8 to buy them. Okay, so write the constraints. The constraints, what I mean by that is you're writing inequalities. Okay, what is limiting us? So why can't we just sell infinitely many or sell thousands of t-shirts and caps? Miranda?
We can only afford to spend as much as $800.
Okay, so this is really important. $800 is all we have. That's all we have to spend. Now, if each t-shirt is $8 and every cap is $4, I'm spending $4 per cap, so 4x. I'm spending $8 per t-shirt. This is going to be less than or equal to 800 because that's all I have. Casey, what else is limiting us? 120 items. We're not going to sell more than that. So what's the left side of the inequality going to look like? X plus Y. So this is the amount of items sold is going to be less than or equal to 120. Now, there's two other inequalities that you're always going to have that a lot of people forget. You must have X is greater than or equal to 0 and Y is greater than or equal to 0. Why? Where do those come from? Miranda?
Because there's a possibility you won't sell any of them.
You won't sell any of them, and we want to make sure X and Y are not negative. It wouldn't make sense to sell a negative amount of something. Okay, so part D, we need to graph our inequalities. If I look at these two, these are in standard form. How do we graph in standard form? The XY chart. Okay, bottom one should be easy. If I put in a 0 for X, I get Y to be 120. If I put a 0 in for Y, I get X to be 120. Top one, we're also going to make an XY chart for. If I put a 0 in for X, I get Y to be 100. If I put a 0 in for y, I get x to be 200. Ooh, sorry, I didn't realize I was off the screen. Okay, I think that this can be kind of difficult from here. We have to figure out how to scale our axes. So I would start by counting how many boxes there are. So do that now. Is there 20? Yeah? Okay. The highest x value we have to go up to is what? 200. 200 is the highest x value. If I have 20 boxes and I need to go up to 200, what am I going to count by? Tens. Are you all writing this down?
Yes, ma'am.
Okay. I don't have enough room, so I'm going to label every other box.
Oh, wait, what?
So I'm still counting by tens, but I'm labeling every other box just because my writing's
Wait,
big.
you're counting by 20s.
No, I'm not. So this is 10, 20,
Oh, yeah.
30, 40. Okay, we have to make sure that we label this axis. So X is the number of caps sold. Okay, now we have an option. On our y-axis, we can change the scaling, or we can still scale by tens. Is there a reason that we need to change our scaling? What's the highest y value we have to get up to?
120.
120. We'll definitely get to 120, so I would suggest not changing the scaling. Just leaving the scaling the way that it is. So again, count up by tens. Okay, now we need to graph our two inequalities. I'm going to start with this one. So first point is 0, 100. Second point is 200, 0. Use a straight edge. You need to be as accurate as you possibly can. Now, there should be shading here, so we need to check for the shading. If I plug in 0, 0, I get 0 is less than or equal to 800. True or false?
True.
True. So we're going to shade towards 0, 0. Okay, next one. I have 0, 120, and 120, 0. And again, you have to connect these. Again, if I plug in 0, 0, I get 0 is less than or equal to 120, which is good. So we're going to shade towards 0, 0. I never labeled my y-axis. Did you guys?
Yeah.
Yeah, you did? Good job. Okay, ultimately, what are we looking for on our graph? What is the region called where they intersect, the shadings? I said this in the video yesterday.
The feasible region.
The feasible region. So that is our feasible region. We need to find all of the vertices. How many vertices are there for our feasible region? 4. We have the origin. We have this one. We have that one. And we have this one. This point looks to be 40, 80. Now, we need to verify that that is in fact the correct point. We happen to be lucky and we are able to see the point. A lot of times your graphs are not going to work out so nicely though. If I did not know what this point was, how could I find it? That's how I can check it, yes. Okay, so Beck said plug this into the equations. So let's plug it in and make sure that they work in both equations. In the first one, I have 4 times 40 plus 8 times 80. So this is 160 plus 640, which is in fact 800. So that's good. In the second equation, I have 40 add 80, so 120 equals 120. That works. But again, what happens if I didn't know that that was the correct point? So what happened if this didn't work out? How could I find the point besides regraphing? Miranda?
Plug it into your calculator.
Yeah. I'm looking for a different way, though. How do you find the point where two lines intersect?
Watch them on 12.
Miranda?
Substitution.
Yeah, substitution or elimination. You solve the system.
Oh yeah.
Oh, yeah. So that's what we're going to do. We have 4x plus 8y, stop whining, equals 800. X plus y equals 120. What do you all prefer, substitution or elimination?
Substitution.
Actually, no, substitution.
Yeah,
Really?
substitute.
Okay, I hate substitution, but that's fine. Bottom equation, I'm going to solve for y. So I get y equals 120 minus x. Doesn't matter which one you solve for. Take notes. This goes in for y. So I get 4x plus 8 times 120 minus x equals 800. So this is 4x, add 960 minus 8x equals 800. 4x minus 8x is negative 4x. If I subtract 960, I get negative 160, which gives me x equals 40. Are you all taking notes?
Yeah.
You have this written down?
Yeah.
You don't have any of this stuff that I have written down on the left side.
Oh yeah, not this.
Did you think some of it was optional?
Yeah.
That I was just writing because I like to write?
Yeah.
Oh.
Okay, so you must show me that your point works. So if it works in the equations, you're good and you can move on. If you do not show this, I will take an entire point off.
For no work.
For no work. Now, if it doesn't work, you have to solve the system to find your point. Is that clear?
Yeah.
Okay. Questions?
No.
Maria?
So, like, only for 1 point.
Right, just for the point where they intersect. Okay, we are not finished yet.
Oh.
Flip the page. Use a table to determine your maximum profit. This is what you guys did yesterday. We need all of our ordered pairs x, y. And then our profit function was 3x add 4y. So one of them was 0, 0. I don't have my graph, so you guys are going to have to tell me what the other points are.
0, 100.
40, 80. Okay, we're going to plug all of these into our objective function. I'm going to get 0 equals 0, which is 0. Here I'm going to get 0 add 400, which is 400. Here I'm going to have 3 times 120. What's 3 times 120? 360. Okay, and then we have 3 times 40, add 4 times 80, which, yeah, it's 440. We want maximum profit. This is our maximum profit. So, part F, write a sentence explaining your answer. The problem was, how many caps and t-shirt sales are needed to maximize profit? Did someone say a lot? Please don't write that as your sentence.
Oh.
What does this point mean, the 40-80? Miranda, question or answer?
Answer.
Okay.
You need to sell 40 caps and 80 t-shirts to get the maximum profit.
Perfect. We need to sell 40 caps and 80 t-shirts for a maximum profit of $440. Okay, do we have any questions on how to answer these problems, A, or B, what my expectations are? Maria?
You don't need to put, like, the points, right? When you have to write a sentence for that type of problem. Just like, for the video, you have to do, like, 180 is next add 40, 80.
No, as long as you put it in context here, like with the meaning of the problem, that is enough for me. Okay, again, one thing I want to point out real quick. The question you are asked tells you what your variables are and what your objective is. So you have one problem like this tonight, and you have 2 more in class on Monday. There is one of these on your quiz on Tuesday.